Hi there, Science 9. So this is your last lesson in the chemistry unit. After this, we're starting the unit on nutrient cycles. And what we're looking at today is what are called binary covalent compounds. So what does that mean? So far in the course, you've looked at ionic compounds. I've told you that those are usually formed between a metal and a non-metal. And that in an ionic compound, the metal gives its electrons, the non-metal takes them. Sometimes the non-metals are just not one atom, but several atoms. But the non-metals are taking them, accepting them. Metals are giving them away. The metal gets a positive charge, non-metal negative charge, and you get an ionic compound, which is also called a salt out of that, little crystals. What we're looking at today are different. They're binary covalent compounds. The binary part means the ones that we're looking at have only got two elements. And also that the elements in question are non-metals. We're not looking at metals because we're interested in cases where electrons are not being totally given away, but they're being shared. That's what's happening by definition in a compound that's got covalent bonds. So what would be an example of that? Well, I made a model of one using these plastic balls. So in this model, I'm going to walk you through a little bit. First of all, the gray things are bonds. You might remember I showed you this in the unit in the lesson on crystals. I said how we've got bonds here. Each of the colors corresponds to an element. This one is for chlorine. The purple ball means phosphorus. This, by the way, you don't need to know about that until Chemistry 11, but I'll tell you now, these are electrons that are not in any kind of bond. They're just on that atom only. This is a compound that we can name. 1 atom of phosphorus and 3 atoms of chlorine. You use the same kind of formula writing methods as you use for ionic compounds. 1 phosphorus, well, let's see now. Phosphorus has a symbol P. Chlorine has a symbol Cl. We've got 3 of these and 1 of these. This makes that this phosphorus trichloride. Let me get to that though. Let me back up and say the formula is PCl3. Today what I want to teach you is how to get the names. So let's look at where we're at for the notes. So in a covalent compound, electrons are being shared. So in a labeled example molecule like you see here, I've drawn this up. This is what I just showed you as a model. The P for the phosphorus atom is in the middle, and it's bonded with single bonds to 3 chlorine atoms. So that's what's meant to be showed by a diagram of a molecule. There's going to be more of those later. The question for you guys is, how do you name these things? How do you name those molecules, and how do you give formulas for them? For most of the questions for today's worksheet, you're going to be given a formula and then give a name, or you're going to be given a name and then give a formula. The method for this is very similar to ionic compound naming in the sense that it's like a first name, last name situation. With ionic compounds, the first name was the metal giving the electrons, last name was the non-metal which took them. Here, it's a little bit different. The first name part of that is going to be the element that is furthest from fluorine in the periodic table. Then the second element, because there's only 2 elements in play, will be the one that's a bit closer to fluorine in the periodic table. Fluorine, by the way, is at the top right of the periodic table if you ignore the noble gases. So closest, the furthest from fluorine is what you start with. You don't have to know that rule for most of the questions for today. What do you do if you've got a formula and you want a name and backwards? So it's like this. Your name for this chemical must have 2 things. The elements that are there, and also how many atoms there are of each element, because these things are present in molecules. This is one tiny chunk of this, or piece of this, phosphorus trichloride. You need to know how many atoms there are of each element in a molecule of that compound. So here's how that works. You need to use prefixes. By the way, I'm just going to show you right now. These are the answers for questions 1 and 2. Those prefixes are based on a Greek system where you use mono is 1, di is 2, tri is 3, all the way up to deca, which I've given you. I'm not saying them all because 2 reasons. They're in your worksheet and they're also in your notes. A prefix is a part of a word that comes before the rest of the word. So if you want to know how many atoms of chlorine you've got in this molecule, we say that before we say that there's chlorine. We put tri. That means 3 chlorine atoms in one of these molecules of phosphorus trichloride. Notice something else I did there for the name. The first part of the name, you just want to say the prefix with the element name. The second part of the name, just like for ionic compounds, you drop the last syllable or 2 and you put "ide." Remember I told you, like, say, magnesium oxide. I said that's an ionic compound. We had for oxygen, we took off the Aegean part of that element name and we put "ide" instead. It's the same way for the second element in a binary covalent compound. As for, there's another little detail to know here as well, and that is a lot of the time you're going to see cases where you've only got 1 atom of the first element in that compound. You've heard of one a lot. You probably know if I say to you, oh, CO2, you've probably heard about the chemical CO2. You might know that that's carbon dioxide. No one says monocarbon dioxide. You just say carbon dioxide. If you don't have that mono part, it's just recognize that there's only 1 carbon atom there. So I'd like to work through a few more of these. And looking at question 3 is the next thing I wanted to go through. I want to be clear about something. The rules I'm giving you for today, for naming and for formulas, don't apply for when we're dealing with metals, and they don't apply for compounds that have carbon and hydrogen in them. In fact, none of the examples where I need you to use the rules have got hydrogen in them. There's 4 compounds I'm starting with to show you that as soon as you include hydrogen or carbon and hydrogen, whatever, in your examples, the naming rules get different. You can have carbon and not hydrogen, and the rules work. But if you have carbon and hydrogen, the rules are out the window. 4 compounds that I list are H2O, NH3, C6H6, and CH4. This is question 3, A, B, C, and D. There's a video you can watch. It's called DHMO, or it's about DHMO. People were told, oh, there's this terrible compound, DHMO, that it's found in all corpses and all cancerous tumors, and it's used in most pesticides and so on and so forth. And people were told, should we ban DHMO? And most people on the street ask this question, say, oh yes, we should ban DHMO. And then it comes out later, well, DH is dihydrogen, and the MO means monoxide. Dihydrogen monoxide, 2 hydrogens, 1 oxygen, or H2O. H2O is water. No one would want to ban water. The next chemical is one that has hydrogen in it again as well. This is an example of where we see a common name being used instead of like a formal binary covalent name. NH3, instead of calling it, say, nitrogen trihydride, it's called simply ammonia. It's known by its common name. C6H6, I only list that because it's a common toxin, but also you don't use those naming rules for it. C6H6 is benzene, and methane is CH4, which I hope at least some of you already know. That's the stuff that I use when I'm burning natural gas through the Bunsen burner. But how about the things where you're going to apply the rules? Question 5 deals with 4 of those. I'm going to walk to the board because this is what I already showed you. For question 5, the first one is CCl4. So what's the name for that? Well, C is carbon. How would you know that? You know that from the periodic table. The Cl is chlorine, but we don't. We also need to say how many chlorine atoms there are. Well, CCl4 means that there's 4 chlorine atoms. So it's carbon tetra. And then remember, we also need to drop the ene and put ide. So that's where it gets to be carbon tetrachloride. Think about that. There were 3 parts of that name. There was that first element, carbon, and then there was the prefix for the chlorine, tetra, and then we had the chloride. All the names are going to be built like that. Carbon tetrachloride. Which elements are there? How many are there of each atom in that compound? The next one is P4O10. Okay, now we've got more than one atom of the first element in there. Let's see, well, what's element P? Go to your periodic table. Oh, it's phosphorus. How many are there? Just 4 of them. So it's tetraphosphorus. So we have tetraphosphorus. This name's going to have 4 parts, 2 prefixes and 2 elements. And the last one, well, how many oxygens do we have? Maybe you already know that oxygen's O. We've got 10 of them. Now, there's a little tiny detail here that I would excuse you for forgetting. It would be common for someone to look at this and say, oh, okay, this must be decaoxide. And even I've made that mistake in the past. What you actually need to do is to drop the A that comes before the O. And so it just becomes decoxide. So in summary there, we have tetra for 4, phosphorus, that means 4 phosphorus, dec for 10, oxygens, oxide. That's the parts of that name. And these names are all built that same way. For the next one, we have Si2, Br6. Oh, what's that? Periodic table will tell you, oh, I guess Si is silicon. And there's 2 of them, so this is disilicon. Br is bromine, and there's 6 of them. So this is hexabromide. Disilicon, Si2. Hexabromide, Br6. And those are the parts of that name. Lastly, we have one that I threw in just because it's similar to the one I showed you at the start. PCl5. Again, do remember that if the first element has no subscript, no little number down to the right of it, this means you don't need the mono part. So you don't say monophosphorus, you just say phosphorus. And then it says Cl5. I guess that means that there's 5 chlorine atoms. So pentachloride. Not pentachlorine, but pentachloride. The full name then, phosphorus pentachloride. Going the other way, I'm giving the example of question 7. The questions for 7, the first one is dinitrogen tetroxide. Yeah. So for dinitrogen tetroxide, well, we've got 2 nitrogens, di-nitrogen, and then we've got 4 oxygens, tetraoxide. So we got N2 for the 2 nitrogens, and O4 for the tetraoxides, N2O4. We have another compound, dinitrogen monoxide. Hey, I'd like you to notice something here. This time I needed to use the mon. I didn't say mono, just mon, for the oxygen, because that element came second. You don't put mono at the start ever, but if there's only one atom of that element for the second part of the name, then you do need mono. So dinitrogen monoxide, N2O, just O, because there's only one oxygen atom in there. This is a compound that's got an oxygen atom in the middle and a couple of nitrogen atoms joined onto it. And then nitrogen monoxide is just NO. That's it. We didn't need a mono for the first part of it. We just know that there's only one nitrogen atom. But we do need a mono for the second part, telling us there is just one oxygen atom. Nitrogen monoxide is NO. That's it. The last, for question 10, is a little bit harder. I'm actually giving you some structures of some molecules, saying this is the way that the atoms are bonded together. You tell me the name, and you tell me the formula. And this is where you have to use the rule I told you, that in the name, giving the formula, the one that comes first is the one that is furthest from fluorine. Now you could start asking me, well, Mr. Coop, what if they're the equal distance from fluorine? There is a more detailed, more specific rule that I could get into, but I won't right now. I will tell you this. Here we have a compound that has one carbon atom in the middle and 4 bromine atoms around it. So, carbon is the furthest from fluorine. I'm checking that. Yes. Carbon really is the furthest from fluorine. So it comes first in the name, as well as first in the formula. Bromine is going to be second in it. Now, remember, we're going to have to drop the ene part from bromine and put on ide. Where does that leave us? It leaves us with CBr4, and we're going to call it carbon tetrabromide. In fact, you know what? I'll leave the rest of them for you guys to figure out. But similarly here, for the second one, we've got, all those rules are going to work for the others that follow. So that's all I need you to know for binary covalent compounds. Naming, giving structures, and giving formulas. And I will put the worksheet up and hope this is useful.